Okay, let's talk about predicting products. Um, when we talk about predicting products, what we're saying is we have these types of reactions that we already know. Let's try to predict products from the beginning points. So if I were to give you two different elements or two different compounds and say this is a synthesis reaction, you should be able to tell me what the products of that reaction are. Um, but just to recall from our previous conversations, we talked about these reactions and these types of reactions. We had our synthesis reactions, which are the A plus B becomes AB. We have a decomposition reaction, which is where we basically do the opposite of a synthesis reaction. That's when we take AB and we split it up into individual elements or compounds A and B. We also have a single replacement where if we take A plus BC, will become AC plus B. So what's happening is our B and our our A and our B are switching places here. So just one element is being replaced, one swap is happening, and so it is a single replacement. Finally, we have our double replacements, which when we have AB plus XY, that ends up becoming AY plus XB. And notice how the positions of each of these things are really important. Notice how in the A, in the before, in our reactant side, A is first. Notice in the product side, A is also first. B is second in our reactant side. B is second in our product side. Also, we can do the same thing for X. X is first, X is still first. And finally, Y is last, Y or second, and Y is also second. So when we have a double replacement, the position of those things matters, right? So if I have something like, for instance, a lithium chloride plus magnesium bromide, I'm not going to have a situation where I produce something like where I produce something like chlorine bromide. That does not happen because chlorine and bromine are both -1 ions. If they're negative, they are like charges, and like charges will repel, so this compound will not happen. Instead, what will happen is we have our lithium will switch its chlorine out for a bromine, and the magnesium Mg will switch its bromine for that chlorine, right? And we will get something similar in shape and size. So if you look at these things, you can see that there's some sort of pattern going on, and we just have to be able to pick out that pattern and use that to predict our products. The easiest one to predict products for, however, is definitely the combustion reaction, because combustion reactions produce two things and only two things, and that is CO2 and H2O, nothing else, right? So there is no other predictions you need to do when you do a combustion reaction. You just need to balance that equation, which can be kind of difficult at times. Anyways, so for a step-by-step process, if we're going to predict our single replacement reactions, the first thing that we need to do is determine if the element that is by itself is a metal or a non-metal. So let's use this example we have up here. It says that 4 aluminums plus 3 O2s, or let's modify that. 4 aluminums plus, let's see, 3 lithium oxides becomes lithium metal plus an iron oxide, FeO, or sorry, not aluminum, or not iron, becomes aluminum oxide, Al2O3. When this happens, you can see that the oxygen was originally with our lithium and it is going to our aluminum. But the single element here that we're talking about is this aluminum, right? So aluminum is by itself, and that is our single thing. So if it's a metal, then what we're going to do is we're going to replace the metal on the compound. Here's our compound. The metal is lithium. I'm now going to replace my lithium with an aluminum, and my lithium will now be by itself on the other side, just like you see here, and my aluminum will be part of that compound over here. It's a little messy, sorry about that. If it is a non-metal, things get a little bit different, but not too different. So for instance, if I have lithium bromide plus F2 gas, so fluorine gas, it'll produce lithium fluoride plus bromine gas, so Br2. what we're doing here is we see that the thing that's by itself is a nonmetal, fluorine, right? It's on the right side of our periodic table. It's on the right of that metalloid staircase, so it is a nonmetal. So fluorine is the single element by itself, and it's going to basically kick off the other nonmetal. So I have my fluorine kicking off that bromine and replacing it and giving me lithium fluoride plus bromine gas. So for example, we have aluminum plus copper 2 nitrate. In this case, we can see that the thing that is by itself is aluminum, so it is a metal. So what we're going to do is we're going to take our CuSO4, we're going to kick it off, that copper, and we're going to replace it with aluminum. Now here's the tricky part though. We have to be able to balance our charges, so we have to think about our charges. I know my aluminum is going to be part of the compound, and the thing that gets kicked off is copper, so my aluminum will be stuck with a SO4. I should know from my polyatomic ion list that SO4 is a 2 minus charge. I should also know that aluminum is a type 1 metal and it has a 3 plus charge. So I will then crisscross my SO4 and my aluminum charges, giving me Al2, right, Al2, and SO4 3, SO4 3. Then I know that the thing that's going to be by itself after the reaction happens is copper, because originally copper was with SO4 and it gets kicked off. So it's left by itself. All that we have to do is write Al2SO43 and then copper, and from there we just have to balance our equations like we've done already. So if I were to be told that aluminum will react with CuSO4 and asked to predict the products for it, I would follow that same step-by-step process. I would determine that aluminum is by itself, it's our metal. That means our aluminum is going to replace the copper metal in our CuSO4. I would get my Al2SO4 3, and the thing that's left over is copper, and from here it's just a balancing equations, right? We have to take 2 of these aluminums and 3 of these CuSO4s to produce 1 aluminum and 3 copper, 1 aluminum sulfite and copper. All right, if we have a double replacement, this one's actually fairly easy to do. Usually in a double replacement, just things will swap partners, and we'll do a little activity about this when I get back. But for example, if I have 2 sodium chlorides right down here, 2 NaCl and a beryllium hydroxide, what's going to happen is the sodium and the beryllium, they're both going to change partners. So sodium's partner in the reactant side on the left side is chlorine. But afterwards, it's going to have OH as its partner because we are replacing the chlorines on the NaCl and replacing them with OHs. And same thing, beryllium, Be, it has hydroxides, OH, as a partner. And on the other side of the reaction, once the reaction has occurred, it is now going to lose that OH partner and gain a Cl partner, right? So we are both swapping those things around, and both of our metals, beryllium and sodium, change their partners. So if I was asked to do this with just NaCl and BeOH2, what I would do is I would say, okay, here's our original starting point, NaCl plus BeOH2, and from there I can do my predicting product stuff, right? So I'm going to swap my Cl and my OH around. They will trade places. So I will end up with Na, and I know Na is a +1, and I know OH is a -1, so it only takes 1 of each. And I will also get a beryllium with a chlorine. But beryllium is a +2, and chlorine is a -1, so I will need 2 negative charges from one from each chlorine to balance out the positive 2 charge on the beryllium, right? So this is what I get, and from here, all I have to do is go about balancing my equations like I did before. I put a 2 in front of my NaCl2 to balance my Cls. I put a 2 in front of my NaOH to balance out my Nas and my OHs, and then we're good to go. Again, predicting the products of combustion reactions is really easy, really easy. It's CO2 and H2O. Once you know that you're reacting something that has carbons and hydrogens only and is reacting with O2 gas, you know that the reaction is going to always yield CO2 and H2O. So it's really simple because, that's the definition of a combustion reaction. The hard part is then balancing that combustion reaction in the products. But we'll do some practice with that later. All right. We could also do some of these problems, right? So if I have a solution of potassium sulfate and barium nitrate and I mix them, right? So this is a problem where been given the words, right? The names of these compounds. And from these names, we're going to have to come up with the formulas. So I know potassium is K. I know it is a +1. I know that sulfate is SO4. I know sulfate is a 2 minus charge. I know that from my polyatomic ion list, which you should have written down in the back of your periodic table. If you didn't, you should do it now. Like pause the video right now and write them all down. Make sure you have their formulas, their charges, and their names like sulfate. Okay, so I know SO4 is a 2 minus. I crisscross my charge. My 2 for my sulfate goes with potassium. I get K2. My 1 for my potassium charge goes with the sulfate. And my formula is K2SO4. From there, I would have a barium nitrate. So I know barium, Ba, is a +2 charge because it's on the second column of the periodic table. I know nitrate is a NO3. And no nitrate has a -1 charge. So if I crisscross my charges, I would get Ba. There would be just one of them, but remember, we don't write ones in our formulas. So it's just Ba, and then parentheses, NO3 and 2. Right? And that 2 comes from the 2 plus charge of barium. Then from there, I just do we'll look at it. We have a metal and a nonmetal, a metal and a nonmetal, and they're just going to switch partners. So this is a double replacement type of reaction. So all I have to do is say if potassium is with sulfate before and barium is with nitrate after, they're going to trade partners. So my barium with a 2 plus charge is going to go with my sulfate, SO4, with a 2 minus charge. My potassium with a +1 charge is going to go with my nitrate with a -1 charge. And so I can then write out my full formula, which is given to you here in red. It says K2SO4 plus BaNO3 2 becomes 2 of the KNO3s plus a BaSO4. And you can see that the Ks were originally with SO4. After the reaction, K is now with NO3. Ba is with NO3 before the reaction, and it's with SO4 afterwards, right? Make sure that your charge is balanced when you do this, otherwise you can lose some serious points, right? Zinc metal is added to a solution of sulfuric acid. So sulfuric acid, and we'll probably talk a little bit about naming convention for acids here pretty soon, but sulfuric acid is H2SO4. Zinc metal is just zinc, right? The element zinc. Here you can see that there's a metal, something by itself, and you can see a compound that is going to react with it. So this to me looks like a single replacement reaction because what I have is an A plus BC becomes AC plus, or sorry, A, it's going to be AC plus B, yeah. So this is a single replacement reaction. If someone told me that's zinc and H2SO4 or sulfuric acid, I should be able to reason using my balancing equation stuff, or sorry, using my single replacement equations general form, that the result is going to be zinc is kicking off those hydrogens and replacing those hydrogens on the sulfate. So it'll produce a ZnSO4, and then the H's that were on the SO4 will get kicked off and they'll be by themselves with H2. Finally, we have dicarbon hexahydride. So this is one of those nonmetals, or sorry, two nonmetals bonded together, I guess. It is a dicarbon, so we'd have C2. We'd have hexahydride, which is H for hydride, and there are hexa of them, so there are 8. Or sorry, hexa, that's octa. It is C2H6. And if it's a combustion reaction, right, we can see that is a carbon and a hydrogen, or a hydrocarbon. It is reacting with oxygen gas, so that has to be a combustion reaction, and it's going to yield some CO2s and some H2Os, right? So if I'm told this, just looking at it, I'd just first write out my C2H6. I'd write out that it reacts with O2 gas, and then it produces, well, this looks like a combustion reaction, so it's going to produce CO2 and some H2Os. From there, you just balance your equation and you're done. So there are some practice problems. Here are the solutions to them. I'll give you a little bit of time to view them and to work on them. But I would say pause the video, work through them, and see if you can get the answers. Okay. Also, we have some more extra practice here. So these are just some extra things that you could do just to give that little extra bit of remembering from some of the previous things that we've done. So it's asking you to figure out what kind of equation each of these chemical reactions are. And it's also asking you to write and balance this chemical reaction up here. So those are the solutions for you. Really, really encourage you to do them because if you, excuse me, if you want to do well on this upcoming progress check and quiz, you will need to have a little bit of extra practice, and we'll get some practice in when I get back from my little break here. So until then, I hope to see you again. Good luck, and we'll see you soon.